Here we are, chapter 4. Okay, graphs and transformations. So again, mixed exercises, all of the past and exam questions in the mixed exercises, a few less than in chapter 3. So let's jump in and make a start. Question 2. So on the same axis, draw the curve y equals 6 over x, so reciprocal, and also y equals 1 plus x. Okay, so starting with an x-axis, okay, and a quick labeling up. And I'm sure by the end of the chapter and the videos I will stop putting the arrows and stuff on. Okay, so 1 plus x. So 1 plus x, as we do a sketch, we should be showing everywhere that the graph cuts the axes. Okay, so y equals 1 plus x should go through those two axes there like that. Okay, where's my straight line tool? Okay, cutting through at plus 1 and also minus 1 being a positive x. Okay, so y equals 1 plus x. Next, and now the y equals 6x. So being a positive, okay, means it follows the same diagonal slope as the positive line, meaning we're in the top right quadrant and the bottom right quadrant for this. So we're just going to simply come down here like this, and we are also going to come down here like this, never actually touching those, so that's y equals 6 over x. Okay, so that's part A done. Now then, part B, what does it want? Completely lost the page. Right then, part B is asking for the curves intersect at the points A and B, find the coordinates of A and B. Okay, so we can put both of these together and we can say 6 over x is equal to 1 plus x, multiply through by the x, giving us x plus x squared, meaning we get 0 is equal to minus 6 plus x squared. And so we get 2 and 3. Do we have a quick look? Okay, so yes, we get x equals to 2 and x equals minus 3. So presumably this is minus 3, this is 2. Okay, and the y coordinates, did it want the y coordinates? Curve intersects, find the coordinates, yes. So we can say that y is equal to 6 divided by 2, and also y is equal to 6 divided by minus 3, giving us equals to 3 and equal to minus 2. So this point here is minus 2, and this point up here is 3. So to finish it off, you've got 2, 3, and you've got minus 3, minus 2. Okay, the curve C. Okay, so now we have a curve C with an equation of, let's do it over here, y equals x squared plus px plus q, and p and q are integers, passes through a and b, find the values of p and q. Okay, so we know that it passes through 2 and 3, which means we have a y of 3. Let's take the coordinate of 2, 3. So that means we have 3 equals 2 squared plus 2p plus q. And we also know that it goes through the coordinate of -3 minus 2, which means, give myself a line here, we end up going through -2 is equal to -3 squared minus 3p plus q. Okay, so we can solve these simultaneously. Okay, let's bring this up, have a bit more room. Solve these simultaneously. What do we want to do with that? I think I'm going to make this red side all equal to q. So 3 minus 4 minus 2p equals q, which gives us -1 minus 2p equals q. I'm going to substitute that into the green side here. So we have -2 equals 9 minus 3p plus -1 minus p, 2p. Okay, so bring that -9, 10, 11, -11 minus 3p. That -1 should come across, so that should become a 10, and then -2 should become -5. Okay. -5p, giving us a p is equal to 2. Substitute it back in here. -1. -1 minus 2 times 2 equals q. -4 minus 5 equals q. That all seems fine. Right then, add C to your sketch. So we know that the q is -5. So no doubt you heard someone at the door. Good old Amazon delivery. So where were we? Trying to put this onto the graph. We know it's traveling through this point and this point. We know it's U-shaped, and we know that it is also going through -5. Okay, because Q came out as -5. All right, so with that done, we can come down here, put it through here. That's a terrible graph. I'm going to have to redraw that. So as it comes down, let's come from this angle. Slightly better. Okay, not my best drawing. Okay, and there we are. It probably should, thinking about it, dip down there like that. Okay, minor detail. All right, that will do because it's only a sketch and doesn't need to be perfect. That's better. Okay, a bit more symmetrical. Right then, so that's A, B, C, and D. Okay, on to question 4 is the next exam question in this exercise. So, question 4. Diagram shows the curve with an equation of y equals 5 plus 2 x minus x squared. Okay, and the line with an equation y equals 2. The curve and the line intersect at the points. Find the coordinates of the intersection. So for the benefit of anyone who can't see the book, we have a picture that's roughly like that. Comes across like this, comes across like this, and it's got that labeled as A, B, y equals 2, and y equals 5 plus 2x minus x squared. Okay, with a 0, x and y labelled. Okay, right then. They want to know where this equals or where this crosses. So very simply, simultaneous equations, let's put them both in there together on it. Okay, so 2 equals 5 plus 2x minus x squared, so thus 0 equals 3 because of the minus 2, plus 2x minus x squared. Substituting it all in for the calculator then, okay, we've got coefficients of minus 1 for A, 2 for B, and 3 for C, and that gives us an x equals 3 and an x equals minus 1. Putting them in for the, we don't even need to do the y's because we know they're both at 2. Okay, 4-mark question, find the coordinates of A and B. So that means A is minus 1, 2, and B is 3, 3, 2. There we are. Done. Quick 4 marks. Question 5 then. So we have a function of x is equal to x squared, x minus 1, x minus 3. And they want us to sketch this graph. Okay. So y, x. So what do we have here? We've got x equals 3, x equals 1, and x equals 0 twice. Okay, so we have got 0, 1, and when we multiply this out, we are going to have a power of 4. So x to the power of 4 is a w or an m. Okay, and we also have minus 1 times minus 3, which is plus 3. So we have it going through on the plus 3 of the y-axis. Okay, so now we've got 1, 2, 3, 4, 5. How are we going to make it go through here and here all at the same time? So let's think this through. Because it's a positive, we've got a W shape. So we know we are coming down in this direction. Okay. And we are then coming up here. And we then need to just touch that. And it's quite flat because it's the repeated root before disappearing off in that direction again. But how do we make it go through the 3? The solution to that problem is, of course, that it does not go through the 3, okay, because the x squares here are basically acting as an x plus 0. And when you do 0 times the positive 3, it goes through 0. So it is just that. Okay, so that is f of x. Now then, on the same axis, draw the line, which is y equals 2 minus x. So this one does go through 2, and it's coming in at minus x, so it's coming through, and it's also going to go through here. So like that and like that. Okay, quick label up, y equals 2 minus x. Okay, state the number of real solutions to the equation where they basically are solved. Now then, does it interact with that curve? Because clearly I could draw that curve in various different ways to make it happen. So we're looking at the possibility of 2 solutions or 4 solutions. Okay, how do we find out? The way we can decide is if we have a look at this point, we know that it's on y equals 0 at these 2 roots here. So between 0 and 1 is the only place that this graph can possibly get and touch this line. Okay, so if we just take this and we pretend for a minute that x is equal to, I don't know, a half, and we start substituting it in, then f of x is equal to a quarter, or sorry, a half squared x minus a half, not x minus a half at all, a half minus 1, and a half minus 3, and when you work that out you end up with a quarter times minus a half times minus 2.5. Okay, and when we multiply that together, okay, we get 2.5 times 0.5 times 0.25, and we end up with 5/16. Okay, which is not high enough for it to interact with the graph, the red graph, because at y equals 5/16, then it doesn't happen. Okay, so real solutions equals 2. Finally then, write down the coordinates of the point where the graph with the equation y equals f of x plus 2 crosses the y-axis. So we are looking for where f of x plus 2 crosses the y-axis. So that's going to have everything raising up. It's going to have everything adding 2 to it. So it's still going to be on 0, f of x plus 2, plus 2, plus 2. Let's see, it should just raise everything up by 2, giving us 2 very strange solutions. So plus 2 just raises the whole thing up by 2, meaning that it's going to cross at this point here, coming down here and giving it the whole wiggle like this. And we only want to know where it crosses the y-axis, so no great drama in terms of it is going to cross. It was crossing at 0, 0, and now that was for f of x, and so f of x plus 2 crosses at 0, 2. Okay.